So we've solved absolute value equations graphically. Now we're going to solve the absolute value inequalities graphically. And we're going to do that similar to solving the equations. We're going to set one side as f of x, the other side of the inequality as g of x. We're going to see where they intersect, but we're going to talk, our solution is going to be either where it's above those 2 points of intersection, or below those 2 points of intersection, depending on what the inequality reads, how it reads. So we're going to follow the same steps, which would be set, each side equal to a specific function, graph, intersect, if they intersect, and then state our solution. So I'm going to get you some graph paper. First step in solving graphically is we're going to state each of these as a function. So I'm going to rewrite f of x equals the absolute value of x minus 4 minus 3, and then g of x is going to be 1. No, not yet. We'll figure that out when we do the graphing. We'll take that into consideration. Okay, so on graphing the f of x function, we're going to state the vertex. Aiden, what's the vertex here? Other way around. What's inside is the opposite. So that's going to be positive 4, negative 3. Good. Okay, so let's go ahead and plot that on our graph. Positive 4, negative 3. There's the point. Okay. Now, to find, so Anna, let's use what do we want to use for x to find another point? 0. Okay. So we plug in 0. And when we do that, we're going to get 1. So we're going to plot that point now. And then remember, I have the dashed line that goes through my vertex. So that allows me to reflect the point 0, 1 over that. So that becomes the point 8, 1. And then I can draw the absolute value. So then second step is then to graph g of x equals 1. So that means we go to the 1 on the y-axis, and we're going to draw a horizontal line there. And we're going to pay, when it was equals, when we had an equation rather than an inequality, we would go to where the two graphs intersect, the absolute value and the linear graph intersect, and we would talk about the x values. So we still want to look at where they intersect because that's going to help us. So they intersect here and here. So we will use those values of 0 and 8. However, we want to know where our graph is greater than 1. When it equaled 1, it was at these 2 points right there and there. Greater than means it's going to be above 1. So we will use interval notation, yes. So how do we describe, for the ones on the left here, how do we describe the x values for that graph, Colton? Yep, that is right. So on the left, our x values that are above 1 are from a negative infinity to 0, the x value of 0 right here. And then the values on the right that are above 1 start at 8 and then go to positive infinity. And we wouldn't use a bracket because we don't have an equal sign in our inequality. So that's how we would state that answer. Okay, let's do another one. Okay, so you can kind of work this as I am doing it. We are going to separate this inequality into two functions. So we look at the left. We don't change anything to it. We just look at what's on the left, and we're going to write that as f of x. So f of x equals the absolute value of 2x plus 3. And g of x is going to equal 5. So different function or different inequality, I am going to write my two functions, f of x equals 3 times the absolute value of x minus 7, and then g of x will equal 9. And I'm going to use the vertex. There's nothing being added or subtracted outside of the absolute value, so my vertex is going to be the point 7, 0. So I'm going to plot a point there. And then I am going to use I'm going to use 4. So when I plug in 4 minus 7 would be negative 3. Absolute value of that would be positive 3 times 3 is 9. So I'm going to get the 0.49. And then I'm going to reflect that over this dashed line. There we go. I can draw my absolute value function there. Now I'm going to graph the line g of x equals 9, or graph that function, and so that means I go to the y-axis at 9, and I'm going to draw a horizontal line through it. And I'm going to be ready to state my solution as soon as everybody's got this done. So the green line represents when y equals 9. So our inequality wants to know when our function is going to be less than or equal to 9. So the green line says is where it is equal to 9. This part of the graph is where it is less than 9. Our y values are less than 9. So we want to talk about the x values that give us here to here, that give us y values that are less than or equal to 9. So the very first one is where they intersect. So they intersect right here. What's that x value where they intersect? 4. So we know it starts at 4. And it can equal that, so we would put a bracket, and then all of the values here for x are going to be less than 9 until we reach this point on the right where it will equal 9, and what x value is that? 10. And we would put a bracket because our function or our inequality says less than or equal to. So the interval from 4 to 10 would yield us, for x values, would yield us values that are either less than or equal to 9 if we plugged them into that absolute value inequality. The board in front. Okay, so f of x is that absolute value graph in blue. G of x equals a -6, so that means go down to the y value of -6 and draw a horizontal line there. And our inequality says we want to know when that absolute value function has y values that are less than a -6. So y values less than a -6 would be anything right here. Those are all y values that are less than a -6. So what part of our absolute value function is in that highlighted area? None. So that tells us there is no solution set that would work for this inequality. You could see this algebraically. You could mentally add 5 over and see that we're going to have an absolute value that's less than a -1 and that that's not possible. But here's how it would look graphically. There's no points of intersection, and there are no points that are below that y value of a -6. So we would state our answer in one of two ways. We could say the solution set is empty. It's an empty set, or we could just say no solution is possible. Okay, tomorrow we will have an assignment over this. So, and then Friday we will work on your partner puzzle activity. So, that is it for today.